So we have seen the various types of prime movers that we can find in the power station or power plant. Now let us look at the electrical part of the generators, which is the main part that converts the rotating mechanical energy into electrical energy. That is the alternator. The alternator has two major components or parts. Okay, so the two major components of the alternator, they are the field winding and the armature winding. So the field winding is the part of the generator that produces the magnetic field, rotating magnetic field, while the armature is the part that produces the voltage or the EMF, okay, that will eventually send from your power station into your transmission line and into your distribution system. So the armature is the part that the voltage is induced into. Okay, so we will see, as you can see on your screen, these are the major parts of the alternator. Okay, we have the armature. So on this particular generator, we have the stationary armature. The armature is usually wound on the stator. Okay, so it is here on the stator. Then the feed winding, that is it on the rotor of this particular alternator. So this particular alternator is a rotating field generator or alternator, because the field is on the rotor or the rotating part of the generator. Then like we said earlier, the field is the part that produces the magnetic field. Since it's rotating, as we'll see earlier, because we need rotating magnetic field to induce voltage into the armature winding, which will eventually be sent to this output terminals where your power output will be taken to your transmission transformer and then into your transmission lines. Okay, so now, since what we have here is not a permanent magnet, it is an electromagnet, which means we need a DC voltage to magnetize these field windings. Okay, because that magnetism is needed to induce voltage into our armature. So now, how do we achieve this? If you look at the screen, you will see that we have what is called the exciter. Okay, so this is the exciter unit. It's like a smaller generator within the big generator. Okay, so here we have the exciter armature, and we have the rotating exciter armature, and then we have the stationary exciter field. So what happens is that the voltage that is produced in the exciter armature, okay, is sent to this rectifier, since we need DC voltage at the main feed winding. So it is sent to this rectifier. So the rectifier does the rectification to DC voltage, okay, or conversion to DC voltage. So it is that DC voltage from this rectifier that will eventually be sent to the main feed winding. So when the main feed winding is magnetized, when the main feed winding receives that DC voltage, it will be magnetized. So once it is magnetized, since it's rotating, it will now be able to induce that EMF that we so require into the armature. So this end of the shaft is connected to our prime mover, any of them that we earlier explained. Okay, whether your gas engine, your gas turbine, your diesel engine, or your steam turbine, whichever. So that is what happens. Then this exciter, like we said earlier, is a smaller generator, which means that Its own feed also needs a DC voltage supply. So the feed winding, okay, the feed winding receives its own DC voltage supply from this unit, okay, that is the AVR. So the AVR receives its power from the output of the generator, and then it converts it into the DC voltage that is so required by the exciter feed. Okay, so that will now help to magnetize the exciter feed. In this case, instead of us having a rotating feed, we have a stationary feed at the exciter. Okay, so as the feed is stationary, but the armature is rotating since it is wound on the rotor. So as the exciter armature is rotating, voltage is induced into the exciter armature, which will now be converted to DC voltage by this rectifier. So this is a kind of showing us the relationship between these three components that we have so discussed: the armature, the feed winding, and the exciter. So this is it, as we explained earlier. So this is the stator, okay? On the stator, we have the armature winding. This is the rotor. On the rotor, we have the field winding, okay? Now, this is the exciter. This is the exciter armature, and this is the exciter. On the exciter section of the generator. So now you can see that the AVR receives its power from input power from the output, okay, of the generator. So this input power is taken to the AVR, and then the AVR converts it into DC, okay, plus and minus, which is now sent to the exciter field. And then the exciter feed, having received this DC voltage, will now be magnetized. So after magnetization, it will now induce voltage into the rotating armature, as we explained earlier. So once the rotating armature produces that voltage, it now sends it to the rectifier or the diode plate, okay? That is the rectifier assembly that is on the front of the alternator. That will now convert it into DC that will eventually be sent into the field winding. So that field winding that is magnetized, since it's rotating, it will induce voltage, okay, or EMF into the main generator armature, where we eventually get our output from. So if you look at this, you'll see that we have what is called this exciter is called the rotating exciter unit, okay? There are some generator, and remember this generator too is a rotating feed generator, okay? There are some where we have the feed to be stationary, like we said earlier also. It is fed from the exciter transformer, then it now converts whatever that is fed into it into regulated DC voltage that will now be sent to the feed by slip rings, okay? So in that case, the kind of generator that we'll be having will not be brushless like this, okay? It will be having the brush type excitation system, okay? So we have another training on, you can check out, for more on this, you can check out our training on generators, okay? The alternators on electrical machines, where it is explained in details. Remember, this section is for us to appreciate what we have in our power system, okay? So we're kind of explaining it so that you appreciate how these various components of the power system, they function, how they interact with one another. So That is what happens in the alternator to produce the voltage that we so require from our power station. Okay,